David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower to suit your desire. Second, you can pause the video at any point to jot down questions or catch up with your notes. Third, you can turn on the captions so you can read my words on the screen. Today's lesson is going to provide you tips and tricks for how to move between standard and factored form and glean the necessary information so that you could create a parabola graph. Now, we're not going to do any graphing in this lesson, but any of the questions or examples that we go through, you should be thinking, how would I graph that? Because indeed on a quiz or a test, you could be asked to complete the question by creating an accurate graph. Let's get started. So here are our 2 forms. There's our general form, and here is our factorized form. So let's do an example. Here is f of x in general form, and what we're going to be asked to do here is write in factored form, then list the intercepts. And I'll remind you of what we do. What we do, this is a trinomial, 3 terms, and the a is 1. So there's no number in front of the x squared, which means a is 1. And so what we do here is we look for 2 numbers that multiply to negative 16, but add up to positive 6. And those numbers are negative 8 and those numbers are 8 and negative 2. So what we get is f of x equals x plus 8 and x minus 2. Now, if you FOIL this, first, outside, inside, last, and combine the middle terms, you're going to get back to this. So we're going to spend a little more time later on that, but right now, this is your basic factoring technique, takes you all the way over to factored form. Now we can answer the question, then list the intercepts. So the x-intercepts are super easy. You just change the sign of the numbers. So we have minus 8, 0, and then we also have 2, 0, like that. And then, of course, from our last lesson, to get the y-intercept, we go back up to the general form, and the y-intercept is just 0 minus 16. Now, from these 3 points, you can create a decent graph. We're not going to do that today, but know that you could be on the hook to do that. All right, let's do that again. New quadratic. Now, you want to think about your factoring. This one is not a simple product sum factoring because we have a number other than 1 for our a term. So I'll give you a hint. This is going to be a split the middle term type factoring. So I have prior lessons that are up on YouTube. If you want to ask, if you need a link to one of those, just post it in the comments and I'll send you a link. If you're in my class, that lesson is going to be on the Math 2 master list for all the videos that were offered in that class. It's called Splitting the Middle Term. All right, a quick review of splitting the middle term. What I do is I multiply my a term by my c term. So that's finding the AC. So I did 3 times 10 and I got 30. So now that I know my AC, I need 2 factors of AC that when added together make the b term, which is minus 11. So I did my thinking, my critical thinking, and I realized that minus 5 times minus 6 is positive 30, but minus 5 plus minus 6 is minus 11. So now, all I do is I split my middle term. Remember, the middle term is minus 11x. So I just broke it into minus 6 and minus 5. It's still minus 11x. It's just split. And then I can factor the first 2. Here, I get a 3x out of both of those. Second 2, I get a minus 5 out of both of those. And now I take my first 2 here, the 3x minus 5. That becomes one of my factors. And then here, my x minus 2 is the other factor. And that gives me my factorized version of that quadratic. All right, I got rid of all that to give us space to do what the problem was asking, was finding the intercepts. So now that you've got that, go ahead and pause the video and find the intercepts for me. All right, maybe you struggled a little bit there. This intercept is pretty straightforward. This is just the point 2, 0. However, this one, I've got a 3 in front of my x. And if you recall, my factorized form doesn't have a number in front of the x. It's just the x all by itself. So how might I address that issue? What I'm going to do is I'm going to factor a 3 out of both of these terms and get a slightly different version of my factorized form. I'm going to get 3 times x minus 5 over 3. Okay, so that's what happens when you take a 3 out of 5. It's just 5 divided by 3. And let's bring this one down, x minus 2. This is the same function. It's just written completely in factorized form. So now my next x-intercept is just going to be the point 5/3, 0. Now finish it up. If you haven't listed the y-intercept, go ahead and do that. So here's your y-intercept, 0, 10, just grabbed right here from our general form equation. Now, we could also get that here. We would just put in 0 for x and do minus 5/3 times negative 2 times 3, and that would also give us 10. But since we have the general form, we're going to use that. All right, here's one that's a little bit more tricky. Requires a little bit more critical thinking. So here's my quadratic. It's got a square. It's going to make a parabola. This is a quadratic equation, but I don't have a constant term out there. There's no number out there. So what I can do, actually, I want you to pause the video and let's think first about the y-intercept. Remember, you can grab that really easily from general form. This equation is a completely valid general form. So what would the y-intercept be? Okay, I'll give you a hint. We don't write this, but that's there, plus 0. Now think about it. What is the y-intercept? The y-intercept is the point 0, 0. So y-intercept, 0, 0. Okay, so if you don't have a c term on your quadratic, you know that the y-intercept is at the origin. All right, so now I want you to convert this to factorized form. And you can leave the 0 out of it because it's not relevant for factoring. So go ahead and see what you get with that. All right, so what I did is I remembered that in factorized form, I don't want any coefficients on x. So I notice what I have here is I have a negative 4 on the x squared. So I factored that out. So I got a minus 4x times x. See, there's my nice x with no coefficients. If I factor a negative 4 out of positive 2, I get minus 1/2. Now, does that look like factorized form? Nope, not quite. I need 2 sets of parens. So again, another critical thinking step here. How could I convert that equation into factorized form? All right, so the trick I used here was I realized that this x could be x minus 0. That's fine. And it's negative 4 times this times that. So here's my negative 4. So here is my x minus 0. I put that in for that. And then I just brought down my x minus 1/2 from there. So that is the true factorized form for this quadratic. A little tricky? Yeah, a little tricky. But ultimately, it works and it is straightforward. So now, pause the video and tell me the 2 x-intercepts. All right, so here they are. I have 0, 0, and minus 1/2, 0. So now I have my 3 intercepts. Now I want you to take a look and tell me what you think this means. One of my x-intercepts is 0, 0, and my y-intercept is 0, 0. That's kind of weird. What's going on with that? What I'd like you to do is make a quick sketch of this graph with these 3 intercepts and see if that tells you what's happening. All right, let's take a look at that graph. What I did is I put my minus 1/2, 0 here and my 0, 0 there, which is both the x and the y-intercept. And that has to be because the point 0, 0 is where the x and y axes meet. So if either the x-intercept or the y-intercept is 0, 0, it means the other one is also going to be 0, 0. And so I got these 2 points here, and then I know that my graph has to open down and it has to be pretty compressed. Down for the negative and compressed for the 4. It's much bigger than 1. So there's my parabola graph, and that's how that worked out. All right, here's one, and I'm going to ask you to find the whole shebang. So here it is in factorized form. Okay, so you've got a few things for free right away. So I'm going to ask you to convert it to general form find the intercepts, find the symmetry axis, and find the vertex. Now, when you see a question like this, you should take a look at the whole picture. Okay, so if you just start marching through, you're going to start converting to general form. But you can see here that I also want the intercepts. So maybe find the intercepts first because they're right in front of you. Okay, but up to you. I want you to find all this stuff, pause video, and come back. Alrighty, let's see how you did. So, like I said before, I grabbed my intercepts right away. They're here. 1, 0, minus 2, 0. Done. Second thing, I went ahead and went to general form. So what I did is I expanded these two terms and got 3 times x squared plus x minus 2, and I combined my middle terms. That leaves us with an x in the middle. And then what I did is I applied my 3 across the board, so I get 3x squared plus 3x minus 6. Then I went, okay, here's the y-intercept, got that. So I went ahead and just wrote that down. So I've got my general form, my x-intercept, my y-intercept. Now I have to find the symmetry axis. Now, if you did this step, you realize it got really fractiony. So I want to take a little time to go through that. You're certainly on the hook for dealing with these kinds of things. So the symmetry axis, the minus b over 2a gives us negative 1/2. That was pretty straightforward. But then to find the y-coordinate of the vertex, we had to put minus 1/2 back into the function to figure out what the y-coordinate of the vertex was. So what I'm doing is f of negative 1/2, and I'm using my factored form of the function to do this math. So what I have is 3 times minus 1/2 minus 1 times minus 1/2 plus 2. I work that through, multiply straight across, I get minus 27 over 4 as my y-coordinate. So my vertex is at minus 1/2 minus 27 over 4. One last problem, I promise. Here is your function. Here are your marching orders. We want to see general form, we want the intercepts, we want the symmetry axis, we want the vertex, and we do want a graph. So go ahead and pause the video, look at the requests, figure out the best order to find all those things, do all that work, and come back. All right, let's see how you did. So I recognize this is vertex form. So let's just grab the vertex. It's at 4 minus 2. You just have it right there. Symmetry axis, same thing. It's the x-coordinate of the vertex. So the symmetry axis is at x equals 4. Now we convert to general form. So I squared my binomial, and I got x squared minus 8x plus 16. I multiplied through by my 1/2, and I get this. And then I combine my two constant terms to get a minus 10. So now I have my y-intercept for free. It's just 0 minus 10. Now, if you tried to work the x-intercepts, you might have bumped into some problems. Here's the first step that's a very reasonable one. Over here, what I did is I took my x minus 4 squared and expanded that out to what it really is. So that looks like I could have an x-intercept at 4, 0. But the problem is that this is not the correct form. This is not considered factorized form because we have a minus 2 hanging out there. So factorized form needs to be all these terms multiplied by each other. So this is not a true factorized form. What we're going to find out is that this function does not have an x-intercept. That makes sense. Not all parabolas cross the x-axis. So when we start looking at solutions of quadratics, we're going to find out that this quadratic does not have solutions, hence no x-intercepts. But that comes later. So now, go ahead and pause the video. If you haven't made your graph, make your graph. All right, let's see how you did with the graph. Here we are. I plotted my vertex at 4 minus 2. Again, here's my axis of symmetry going right through there at x equals 4. Here's my y-intercept at negative 10, 0. And I can reflect this y-intercept across the axis of symmetry and get the point 8 minus 10 as another point, a third point for my parabola. Sketch in the curve, and there you go.